My name is Dr. Gold. This is Office Hours, a stream that helps you out with math, homework, science, homework.
Oh, yeah.
All sorts of fun stuff. We are live on TikTok. We are live on Twitch. We are live on YouTube. Give me a second to get all those chats integrated. What's up, Reki? I haven't seen Reki in a while either, dude. Where you guys been? Reki, I know you got math, dude. This was a fun one. What was it? We're doing like the remainder theorem on this. I like this. This is a cool one. But okay, here. Let's pop up Odin's first question here for the day. And then it looks like we're going to do the chain rule. That's fun. I like the chain rule. I feel like the chain rule is another thing that's taught wrong a lot. You did learn last week? Great. What did you learn? I'm really happy that you learned, but like, what did you learn? Let me make sure TikTok's running here. The remainder theorem. Oh, yeah, nice. Are you literally studying the remainder theorem? That's really cool. Then that's kind of related to what we were doing. Yeah, we did a little bit that with this. I was searching for this. Yeah, what's up, DMs? Yeah, sorry. Yeah, welcome, dude. Yeah, so DMs, I will always start the streams on Twitch earlier to just kind of like get all the formal announcement stuff out of the way. And then it'll be like 5, 10, 15 minutes sometimes when I start it on... I don't start on YouTube and TikTok until we're actually doing questions. Because otherwise the algorithm doesn't know really where to place me. It's like, yo, is this guy just like yapping or some shit? It's like, no, I actually do math and science. So once we start doing questions, I'll turn on the streams. Rational root theorem. That's a good one too. Yeah, rational root theorem is pretty cool. I would love for my TikTok chat to work though. We do get a lot of people on TikTok. One second. Sometimes you gotta like mess with it a little bit. Yes, all good. I know this will eventually load. There you go. I think I gotta like click on my stream here. Come on. Nice. Yes, I do need to do all the point redemptions. I will do those soon. Okay. I hope it loads. Come on. Come on, TikTok. I know you're there. Oh, there it goes. Cool. All right. TikTok's working. It just takes a second sometimes. And then there. Let's see if that comes in on the chat. Yes. Yes, chat. Whatever. We'll figure it out eventually. Okay. Draw the appropriate chain rule diagram and explicitly write out the appropriate chain rule. Then find the WDV at UV of 2, 1. What's up, Jeff? Good to see you. Okay, there you go. Now my chat works. Okay. But does this chat not work? You're adding to the strategic reserves?
Nice.
Nice. Oh, I don't know. Okay. Not approved. Oh, you know what? TikTok doesn't let me put... I can't put URLs, really? Oh, one sec. Let me fix this on TikTok. That's so dumb. One sec. Okay. Well, we'll figure this out at some point. All right. D omega dv. Oh, interesting. And we have w, x, and y, which are all like kind of functions of each other. Okay. So dw dv is the same thing as, let's say, dw dx times dx du, right? I believe this would work. And maybe plus d omega dy plus dy du. But then do I need the v stuff too? It says draw a diagram. It's kind of fun. Oh, no, that's a q. Yeah, I think they want us to... Let me try to get this. I mean, to differentiate x cubed, you get 3x squared plus dx du. Yeah, okay, I see. Do we really want to go through and do all this? I feel like... Well, let's see. Okay, so omega, or w, is a function of x and y, right? But x is a function of u and v, and y is also a function of u and v. Okay? So I think this is how you have to do this. I think you have to do d omega dx du plus d omega dx dv plus d omega dy du plus d omega dy dv. I think that's like the total chain rule, because this thing is dependent on two different variables, and so we have to know how much it depends on x. Yes, derivatives. When it's you can't comprehend this, is just the chain rule. I don't think this is too bad. Oh, but we only need it with respect to v. So I don't need these ones, right? This would be the full derivative. Right, exactly. Yeah, we don't need this. And we don't need this one. We only need these two. Yeah, that would be the full derivative. Okay. So yes, d omega dv is just equal to all this. Okay, cool. All right, this is not too bad. All right, let's get it. D omega dx. So let's derive this with respect to x. And that means we only treat x as the variable that we're doing derivatives. So that's going to be 3x squared. And then derivative of y over x with respect to x is going to be negative y over x squared. Okay. Well, here's a good question, DM squared. Do you know about derivatives? Do you know how derivatives work, for instance? Just a little mini lesson here, right? If I do d dx of x to the fourth, do you know what this is? It's okay. So what happens is you take this, you bring it down, so that becomes 4x, and then you drop the exponent by 1, and it's 4x cubed. Yeah, so this is how we take like regular derivatives. Now, there's something called the chain rule, which is if, for instance, let's say we had something a little bit more complicated. Let's say I had d dx of... Yeah, this is like A levels. Power rule is goated, dude. It is. So if you have, for instance, the derivative of something even more complicated. Let's say it was d dx of x to the fourth plus 1, or let's say like plus 3 to the fifth, okay? This is really tricky to do, because what I could do is I could multiply x to the fourth plus 3 times x to the fourth plus 3 times x to the fourth plus 3 and like do it 5 times. But this sucks. You really don't want to do this. It's so much foiling, it's so much expansion, and it's like terrible. Yeah, it's really bad. Just don't do that. So we do something called the chain rule, which is really cool. Let's go. Yeah. So instead, what I do, I like to always kind of like, I like boxes. I'm going to call this a box. Okay. I'm going to say that box here, for instance, is equal to u. Okay. And so instead of doing, and here, let's call this y is equal to this. And I want to figure out what is dy. I want to figure out like what is dy dx. Okay. Well, instead of doing dy dx, which x is locked away in this really ugly to the 5th power thing, I can call this whole thing inside a u. And now instead we have y is equal to u to the 5th. Okay. And I know what dy du is, right? Dy du in this case would be equal to 5u to the 4th. Okay? Now, but when I do the chain rule, and I pretend that everything was inside this box, and I just did a regular power rule, I now need to multiply by the derivative of what was inside the box. So in this case, I now need to multiply by the derivative of this. And that's the derivative of x to the 4th of the 3rd, which this is easy because this is 0. And then this is equal to 4x to the 3rd. What we did here is we did du dx. Okay? So it turns out that here, let's get rid of this. The final answer for this thing, so do a different color. Dy dx is equal to 5 x to the 4th plus 3 times 4x to the 3rd. This part right here that we did, which was this is all 5u, sorry, this is to the 4th. Sorry, to the 4th. What's up, Amies? Exactly, Ezra, thank you. Yep, this is 5u to the 4th, which is the same thing as dy du. And then this 4x to the 3rd we did over here, right? This was the same thing as du dx. Okay, and then look what happens. If I do dy du times du dx is equal to, what, dy du times du dx. These things cancel. And so you're just left with dy dx again. Which is exactly what you wanted. That's just like kind of a proof of the chain rule. It's super handy. Oh, Stony Brook, nice. That's New York, right? What is that? SUNY Stony Brook? Is that where it is? MZs? Ezra says, why are you never allowed to use L'Hopital in your class? Well, I mean, you're only allowed to use L'Hopital, for instance, if you get, what is it? Infinity over infinity or 0 over 0? Yeah, the limit of the top has to be infinity and the limit of the bottom has to be infinity. Or the limit of the top has to be 0 and the limit of the bottom has to be 0. It has to be like indeterminate form. You can't have 1 over 0 or 1 over, well, 1 over infinity would just be 0, but swag, nice. Yeah. Could I please repeat a bit? Yeah. What part did you want me to repeat there? 6. Wow, nice. Good job, MZ. He's about to finish college as a pure math major. Sick. What's next? What's next in life? River says, are you confident in evaluating the limit of compound interest? Yeah, that's just a Taylor expansion, isn't it? I think. Are you talking about like compound interest that's compounded infinitely? Oh, the 5u to the 4th. Okay, cool. Yes. So this part right here, this is called the power rule for derivatives. So whenever you take the derivative of something that just has an exponent on it, all you have to do is multiply the exponent up front and then drop the exponent by 1. So this would become 5u to the 4th. So that's why the derivative of this becomes 5u to the 4th. MZ says, what can I do to strengthen my PhD application? I want to do a PhD in something pure math, maybe crypto or cryptography, sorry. I want to be a professor, but want to do cryptography. Okay, so if you want to be a professor, you need to be involved with research. 100%. What's up, Femvox? Good to see you. So the best way to get on the professor track is to have some sort of research under your belt, and that usually means if you haven't done any research yet, after your degree, you should do what's called like a post-bac or a post-baccalaureate, which is kind of like a postdoc. And a couple schools offer this, but you just do research at a university in math. I think that's what you want to do. REUs, yes, REUs are great. I did an REU. That's how I got into grad school. So 100% I agree with REUs. What's up, Dylan? Yes, good. Yeah, no, very good point there. Yeah, integration, you add one and then you divide by the new power. And that's why they're called antiderivatives, because they're opposite. Okay. Anyways, so this was a more complicated... This is like kind of vector calculus. So what we had here is we had a function omega w, which is a function of x and y, okay? So omega is a function of x and y. However, x is a function of u and v. This is called multivariable calculus, because now instead of just dealing with x's and y's, we're dealing with like x's and y's and z's and all sorts of stuff. So it's not partial integrals, it's partial derivatives. Cleaner's method. Yo, what's a cleaner's method? Becky, we can go over your other one later, or if you just want to resubmit it, if it's not too much trouble. The queue clears automatically like every day. Yeah, I think so too. It uses a Taylor series, right? Yeah. Kramer's rule. Yeah, I could try Kramer's. Okay. So, if we wanted to figure out d omega dv, you have to do d omega dx times dx du. Well, actually, sorry, we didn't want this. No, let's get rid of this. It's d omega dx times dx dv. Notice how this cancels out to get 1 d omega dv. But then you also need d omega dy times d omega dy times dy du. Because then that gets you the other. Wait, sorry, no. My u's and my v's look the same. This is annoying. This is supposed to be a v. I also hate that in math, why they use v's and u's. Like, they're so similar. X and y at least looks different. There we go. This is the one you want. This one and this one. Yeah, we didn't do it already. Yeah. I think I do have it. Yeah, I can go find it. I probably do have it. It should still be there. Just to get your name, like, on the queue so I can see it. Right, because we have a queue of, like, the questions we're going through. So right now, I'm going through Odin's. Next, I'm going to help Indian out, and then we're going to help out River. And then whenever Becky gets hers added. Okay. So, d omega dx was doing this derivative. Okay. Which, this is the same thing. Sometimes it's easier to write everything out just as exponentials. So this is x to the third plus y times x to the negative 1. When x is on the bottom, that's x to the negative exponent. So now the derivative of that is 3x squared. And then the negative 1 comes out, and it's to the negative 2. But anything to the negative 2 is now 1 over x squared. Okay? So that's why we get this for our first d omega dx. Okay? And then we need to get dx dv. Okay, so here's x. So dx dv is a partial derivative where I only care about v's. So u's are treated as constants. I don't care about this. I don't care about this. So this is the only thing we're doing. And the derivative of that, right? Pull the 3 in front. Negative 2 times 3 is negative 6. And then the v to the third becomes a v squared. So that's our next derivative. Okay. Now I need d omega dy. And d omega dy is going to be this. But with respect to y, I don't care about x. And the derivative of y is just 1. So this just becomes 1 over x. Okay, cool. That's easy. GG's. Okay, so then we need dy dv. So now we got to look at our equation for y here. And the only thing there that has a v is that. So that's just going to be 1. Cool. Okay. So now when evaluating d omega dv, that's d omega dx times dx dv. So that's going to be 3x squared minus y over x squared times negative 6v squared plus d omega dy dv. So that's going to be 1 over x times 1. Cool. However, they want us to evaluate this at uv is 2 comma 1. Okay. Because my equation here does have things in terms of v at least, but also has things in terms of x and y. So I have to figure out what x of uv is and what y of uv is. And then this is at, what do we say? 2 comma 1. So we have x at 2 comma 1 and we have y at 2 comma 1. Now we're looking for that. So x was, I just need to like pull all these down. I keep working so much on these. Okay. X of 2, 1 is equal to 2 squared minus 2 times 1 cubed minus 1. So that's 4 minus 2 minus 1. So that's just equal to 1. And then this is 2 times 2 plus 1 minus 2. 4 plus 1 minus 2 is 5 minus 2 is 3. Cool. Okay. So now we can plug things in. So that's 3 times 1 squared minus 3 over 1 squared times negative 6. Now v was 1 plus 1 over x. X in this case is 1 times 1. All right, nice. So I think we're almost done. So this is 3 minus... Well, 3 minus 3. It's just 0. This goes away. I don't even care about any of this. Okay, so 3 minus 3 is 0. So the final answer is just 1? The final answer really just 1? I think it is. Odin, tell me, bro. Is it just 1? It's kind of silly. All that for 1. I know, seriously. One sec. Let me throw this in the chat real quick. ChatGPT usually comes up with it. Oh, you don't know the answer yet? That's okay. Let me just like pull it in. Alright, yeah, so compute the partials. Yeah, says the answer is 1. Nice. We did it.
Well done! Well done!
Nice. Okay. Let's see what... You did all that in community college. Yeah, I mean, yeah, a lot of the stuff can be done in community college. Let's go find the next question. River. Oh, actually, no, not River. Sorry, Indians. Indians is next. And then River. I see yours. And Indians is asking a pretty good question. Yeah. Bro, didn't I tell you this is the confusing one with force diagrams? Yo, I keep having trouble in algebra. I keep forgetting everything. Uh-oh. Sorry you keep forgetting everything. The best way to not forget things is to do things. Like, I haven't really forgotten my name very often, right? And that's because I use my name a lot. So, if you don't want to forget algebra, try using algebra a lot. Or, like, just do practice questions. Yeah, this is the tough one, right? Okay, yeah. Oh, this is so gross. Yeah, because look... Jeff's going to hate me because we're doing physics. But you have two different coefficients of friction. You have a coefficient of friction between the blocks. And then you also have a coefficient of friction between the floor and the lower block. And those things are different. I don't use my name here. I don't use my government name. Thanks for the follow, by the way, Califated. Absolute value stuff's cool, yeah. You know, absolute value, Zach was just going over that today, about what he thinks about teaching absolute value. Depesm? What's depesm? Okay. Force F causes both blocks to cross a distance of 5 meters starting from rest. What is the least amount of time in which this motion can be completed without the top block sliding over the lower block? Wow. Okay. You like what I'm doing? Thanks, man, dude. I appreciate that. I can help you too. If you have a question, right? You want to submit a question? There's a website down there. Just use that website to submit your question. Yeah. I wonder why I can't like type. Let me type this in. Sorry, to into my TikTok chat. I don't know why this isn't working. One sec. Let me see. Let me see that. And then let me see if I can pin this. Under review. Okay, so now it pinned. Okay, wait, can I only pin things for 59 seconds on TikTok? That's gross. What? Terrible. Also, I wanted to see if... where is it? Let's see if this works. Oh, it doesn't work. Okay, we'll figure it out. All right. And then this should work too. Otherwise, it works. No. Oh, now it goes. Oh, there's Nightbot. Nice. Sick. Okay, Nightbot works. Let's draw the 2 blocks, by the way. So here's the situation, Indians. If I want the least amount of time in which the motion can be completed, I want to pull on this block as hard as I can until it slips. Because the second this thing starts slipping, it's not going to pull the bottom block very far, right? Then the bottom block's just going to stay kind of stuck, or it's just going to sit there, right? This one's just going to kind of slide over it. So what we want to do is, yeah, exactly, right? Okay, so let's draw the 2 blocks. I'm going to call this block 1. I'm going to call this block 2. All right. Let's draw block 1. And let me do different colors, actually, for them, maybe. Yeah, let's do different colors. I'm going to call that block 1. I'll call this block 2, because sometimes it helps. Synesthesia, right? All right, so block 1 is going to have M1G pulling down. It's going to have the normal force pointing up, but this is where you have to get tricky with normal force, because it depends like what surface things are on. Block 1 is on block 2. So the normal force, I'm going to call this F21. I do know things about programming, yeah, for sure. So I call this F21, which is the same thing as like FN1. Okay? And then we have a force F. And then we're going to have a force of friction that's pulling it back, right? This thing wants to move forward, but then it's going to have a force of friction that's pulling it back. Okay, cool. Then we have block 2, which is going to also have M2G pointing down. Because the friction, and it's going to have F of the ground on block 1. I'm going to say like, I don't like FG because that's gravity. Let's call this like FN2. Okay, so this is the normal force from the ground exerting on block 2. And additionally, because the red block is on top, feeling F21, the blue block on bottom has to feel F12. This right here is kind of equivalent to the mass times gravity of the top block that's also pushing down on the bottom block. Okay? And then if there is friction between block 1 and block 2 that is pulling to the left on block 1, that friction is going to pull to the right on block 2. This is called a force pair. They're equal and opposite. Action-reaction pairs, exactly, Fembox. But additionally, there's another friction, which I'm gonna call this like F friction 2. And this is the friction of the blue block, the bottom block with the ground. Okay. So you got friction. People get really weirded out about this. They're like, wait, how is friction pulling this thing forward? Friction is the force responsible for translating the pulling force on the top block into pulling the bottom block along with it. And it has to point to the right. It's really weird. I understand. It's weird for like friction to like point in directions. Okay. So we want to know without the top block sliding off the lower block. Okay, so in order for that to happen, the force being pulled can't be greater than the maximum force of friction that can be provided on the top block, on block number 1. So I'm going to set these equal to each other, okay? So I'm going to say F is equal to F friction. And F friction, we know, is going to be equal to mu static. So this is the static friction keeping the red block attached to the blue block, times Fn1, the normal force on here, which is the same thing as F21. And so that's going to be equal to mu s. Since the sum of the forces in the y direction has to be 0, and there's only 2 forces here, Fn1 has to equal m1g. So this will be mu s m1g, and this is going to be equal to F. And this is also equal to F fric, by the way. Okay? This is also the force of friction that is keeping the red block from slipping. Thanks for the follow, Danger. All right. So now that we know that, we can look at our blue block and start to do some calculations. So let's look at, for instance, the sum of the forces in the x direction here, okay? So you have... I have watched Donnie Darko, yeah, of course. You have F friction from the red block, so that interaction, which is pulling it to the right. But then you have this friction from the ground on the blue block, which is trying to pull it back. So that's why that's that. And that's going to be equal to, we're going to say like M2A. All right. Now let's look at the sum of the forces in the y direction. This is a little bit complicated. Okay, I have Fn2 pointing up. But then I have 2 forces pointing down. I have M2G, so that's the mass of the blue block. But then I also have F12, which is basically the mass of the red block. The reason why I'm keeping it as F12 and not M1G right now is that sometimes there will be forces on this top block that end up screwing up F21, which then screws up what F12 is. So you want to get in the practice of using these force pairs and not just immediately defaulting it to M1G. It turns out, right, yes, that F21 equals M1G. Why not be a professor? I have been a professor. I have taught. I've taught physics at UCLA. You're following along? Cool. All right, makes sense? Good. Okay, so then force friction 2, that's equal to mu k. That's the kinetic friction between the blue block on the bottom and the ground. And that's going to be times mu k times Fn2. All right? Now, the interesting thing is I got to get Fn2 from here. I know this is equal to 0 because I need the blue block to not move in the up-down direction. So that tells me that Fn2 is equal to M2G plus F12. And remember that F12 is the same thing as Fn1, which is the same thing as M1G. I want to do AP Physics, but I'm afraid the math might be boring. Should I take it? I mean, you should take AP Calculus, too, if you think math is going to be boring. I will say the math in physics is not too complicated. But if you're taking AP Physics C, you will definitely do some stuff with derivatives and integrals. So I don't think it's boring. It's not super complicated, I guess, but... Okay, so this is M1G. All right. So, let's keep working on this one. So M2A is equal to the force of friction, which the red force of friction we found out was this, right? So that's mu s m1g. And then we're going to say minus mu k. And now Fn2 is all this. Oh, this now comes here. Now this is m2g plus m1g. Cool. What's up, JD? Okay. The next thing is for me to actually get all the numbers from this. So sorry. I need all the... Oh, no. Okay. Because then, eventually, what the question is asking is what is the least amount of time in which the motion can be completed, right? So we need to know the acceleration. Working backwards, right? You know, from this equation for kinematics, x equals x naught plus v naught t plus 1/2 at squared. We assume it starts at 0. We assume it starts at rest. So the time it's going to take to go a distance x, which that distance is 5. So you're going to get 5 times 2 divided by a square rooted is equal to t. If I rearrange this for t, right? So, we got to solve for a. And a comes from here. Yeah. So, yeah. No, you're okay, Lucas. What's the hardest problem you've solved by yourself? And why is it so hard? Honestly, there's someone in our chat named Shanktrix, and he's always giving me these like math challenge questions. Those are pretty hard. The only way I'm able to solve those is because I either have help on the stream from other people that kind of know the answer, or I've seen other similar questions that use similar strategies. That helps a lot too. All right, what is mu s here? 0.6. Okay. So we're going to do 0.6 times m1, which is 4, times 9.8, minus mu k, which is 0.2. And then that's m2, which is 3 times 9.8. I could have pulled the 9.8 out, honestly. Plus 4 times 9.8. Okay. And then that's m2a. So I divide all of that by m2. So that's my acceleration. 3.266. And then we do the square root of 5 times 2, which is 10, divided by that number. It should give us a t of 1.75. 1.75 seconds, I think. Yeah, 1.75 seconds. I'm correct? Nice. Love it. Sick.
Well done! Well done!
Yeah, you can ask whatever. Yeah. So again, if you have a question, there's a website. Sorry, I submit a screenshot and I'll go over it. Yeah. Anyways, yeah, good question there. I have done centripetal acceleration before, but you can ask if you give me a screenshot of a question, I can definitely like figure it out for you. Yeah. Nice. Oh, Nightbot's saying stuff. Good job, Nightbot. Really fun challenges to try and solve the cubic with indeterminate variables. Oh, that sounds difficult. All right, let's see. So, that was Indian fans. Good question. Next up is River, and then Becky with the complex continuation. All right, let's see Rivers. Now, here's the funny thing, River. This is a definition, though, is it not? I mean, what we're talking about here, and the reason why this is applicable is because if you look at, for instance, was it compound interest? This comes up as equation, yeah. Yeah, this is compound interest, which looks pretty similar, right? And then I think what you're looking at is continuous interest. Yeah. Hit E be like, yeah. I wanted to see the equation. And then this is continuous compound interest. I don't dude, this is the okay, there we go. That's what I want. You should ask people who are on Math Stack Exchange to help people's problems like you and make vids on Discord. Yeah, I make a bunch of vids. I'm sure, Lucas, you've seen my profile. Unfortunately, like, making videos just takes a lot of time. So, you know, I have to kind of like set aside like a lot of time to do it. And again, I don't expect everyone to do it. Okay, so yeah, you asked this question, evaluate the following this. The reason why this is useful, you know, I'll try to run through it. Is that compound interest here, this refers to basically you're calculating how much someone owes at certain points during the year. So if something is compounded monthly, for instance, n would be equal to 12 in this case, right? So that means like every month I would go back and calculate how much money you owe me, and I would add that to the total amount you owe me when calculating how much more you owe me. Simple interest is, for instance, if I borrow $1,000 and I say I'm going to charge you simple interest of 5%, then you just owe me $50 at the end of the year. But if I say I'm going to charge you $1,000 at 5% compounded monthly, then that's different, right? We can actually see what the difference would be. I'm actually curious. Yeah. So right, if I give you $1,000, at 5% simple, right? 5% of 1,000 just means you owe $50 at the end. Okay. Let's see how much you would owe if it was compounded monthly. In that case, your principal is how much you start with. So that's 1,000. And then it's 1 plus the rate. So the rate in this case is 0.05. Exactly, Jeff. N is the amount of times it's compounded. That's 12. And then this is to the 12. T is the number of years, but we just said 1 year. So it's just this. So let's see what that is on the calculator. I'm curious. I'm solving this with you guys, you know. We're figuring it out. So 1,000 times 1 plus 0.05 divided by 12. All to the 12th. So that would be 1,051. So that's how much total you owe. So at the end, the interest you end up owing is $51.16. What's up? Moses. How'd your test go? Right. So, yeah, this is a cool thing. So 5% compounded monthly can be seen as, they call this, yes, APR, annual percentage rate, is effectively 5.116%. Right? Okay, but let's say instead of compounded monthly, let's say we did it like daily. Right? If we compounded this daily, all that happens is the 12 here changes to a 365. So let's go back to our calculator. Let's change this to 365. Exactly. Yeah, so how much you owe is the 1,000 plus the 50 in that case, yeah. So 1,050. Yes, we're not going to do quarter of a days. He's right. Okay. So this is 365, right? What? Okay, so in this case, you end up owing 1,051.27. So it's not, there's not really much of a difference, right? Yeah. Okay. Nice. Moses says, the inclined plane problems were so much easier to do with the free body diagrams rather than tilting the axis. It just made so much sense. Nice. I'm glad. Glad it did. Okay. Exactly. So what we can say here is that, okay, instead of compounding monthly, instead of compounding daily, what happens if I compound this at like continuously, which means that like every second of the day I'm compounding this. This is what a limit is, because we're seeing what happens to this function as n starts going to infinity, as I start compounding it an infinite amount of times during the year. And so the way we write that in like calculus is I'll say, okay, so now the amount is equal to the limit as n approaches infinity of p 1 plus r over n to the nt, right? Okay. What I do know, and we'll see if you want me to derive it later, River, but I'll just show you what's given. This is given to us. It's a good derivative to know. It's a good. There are a couple limits you want to know. Where is it? No. Oh, not derivative. Sorry. Limit e to the x. This is it. Yeah. Well, that says x goes to 0. Where is it as we go to infinity? Yeah. Yeah, here we go. I forget which one is given. You can just flip the x and the 1 over x. Yeah, right? Yeah. Right. Because I think the justification for this, right, is that as n approaches infinity, 1 over n approaches 0, right? So I could replace this with like 1 over... I could replace this with 0, and then this gets replaced with like 1 over n, and this gets replaced by 1 over n, which then just becomes this. Exactly, yeah. I think River is asking, how do we derive these, like, from first principles, which we can try to do in a bit. Let me just show how we eventually get to the formula I want. Okay, so notice that this kind of looks like this, right? Kind of does. P is just a constant. So what we can do here is just pull this out front, in front of the limit. So I'm going to say this is equal to P times the limit as n approaches infinity of 1 plus r over n to the nt, yeah? And then the cool thing about... oh, I see what we're going to do here. Yeah, this is actually pretty cool. How do we pull the r out again? I think we just leave it. Could you explain imaginary numbers? Yeah, give me a question on it. I can try to explain it. Let me think. How do we get the r over n again, Jeff? I think this is what I do. I say, yes, r of n is equal to 1 over u. Yeah, okay. Yeah, good. Let r over n equal to 1 over u. Yes. So, as n approaches infinity, right? So if this goes up to infinity, 1 over u also approaches infinity. Sorry, 1 over u approaches 0. Okay, but here, wait. If you rewrite this, sorry, that's what I meant to say. N is equal to ru. So as n approaches infinity, u also approaches infinity. Okay. And then I can rewrite this. So let's see. P, this is called, we're like re-indexing our limit. So instead of n going to infinity, I'm going to say as u goes to infinity. 1 plus r over n is now 1 over u. We're going to call this 1 over u. And now n is equal to ru. So this is rut. Very cool. Watch what happens here. I can also write this. Limit as u goes to infinity I'm in a rut. Oh no. Oh, so sad, dude. Also, wait, where'd my ticker bar go? What? Did we lose our ticker bar? One sec. Where is my ticker? Oh, I just noticed that. We don't have our ticker bar open. Where the fuck did our ticker bar go? Oh, I can explain up to differential equations usually. Yeah, differential equations I'm good with. Wait, I'm just really confused now. Where is my ticker bar? Nice. It just doesn't go? The fuck? Okay, I don't know where that is. All right, we'll find it later. Okay. No, I'm not stumped. No. Sorry, I was stumped with OBS. OBS is like fucking up for some reason. It's okay. All right, sorry. This is 1 plus 1 over u to the r, but that to the u. But then this is also to the, I think it's to the RT, right? Is it the same thing as this, all to the RT as well? Because a to the BCD is equal to the same thing as a to the B to the CD. Exactly, yeah. So this is an exponent rule we should know, right? Yeah. Anytime you have like a bunch of exponents multiplying by each other, you can just start raising them to each other. So great. And then this right here is the same thing as this. Or sorry, this one. Sorry, this one up here. So that's just equal to E. So this whole thing here, this whole thing just goes to E. All of this becomes E. And then we're still to the RT. We still got the P. And that's the amount. And this is the APERT, which is also equal to what compound interest is. Continuous. The Gaussian integral. Yeah, I think he's asking about this. Can I explain this? Yeah, can I explain like why this is equal to E? Let's see. River has given me a Desmos file. You gave me this, right? River? What is this? Cheat and just say it's the definition of E. Okay. Alright, let's see. So, e to the x is... okay, well, that's that number. What is this? It doesn't like this, apparently. F of x is equal to... The integral is equal to the square root of pi. You don't need that. Just set a equal to 100. Okay, yeah, whatever. Am I just supposed to graph this? Oh, sorry. River, are you using Desmos just to like write equations out for me? Yeah, this is what we're trying to I guess show this. It's okay, Aquaman. Yeah, we're just saying evaluate this. Oh, I see what you're doing. Yeah, that's cute. That's really cute, River. Yeah. River's using this to show me like why this works in terms of like, all right. Split using exponent rules. Apply the limit to each of them. Sure. Oh. Oh, is there L'Hopital's rule going in here? Yo. Whoa, 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 whoa. Also, like, are you meaning to say rate here? Why is it R-A-T-E? What am I looking at? I agree. I'm also trying to explain. And it's not N plus T, is it? Wait, what? What's going on here, River? River, we gotta teach you how to, like, maybe just type things up in LaTeX instead of just, like, dumping shit in Desmos. Yeah, cool. What's up? Yeah, come to the stage. Come to the stage. What's up, River? Why is it N plus T? Let's just maybe just get a proof for this one. I think that's what we want. Is that what you want? Because I think we showed why this goes to eventually P e to the RT, right? You just re-index whatever your limit is using U substitution, and then use exponent rules to eventually get to this. Oh, it is? Oh, okay. Try to figure it out, Justin. But if I want to prove that this is true, I'm wondering what that is. Let's see how we prove that. Where's my questions? Okay. I wasn't joking when I said that's one possible definition of E. I know it's a definition of E, but is there a way to show it? Can Khan Academy help me learn how to do these, like, as a complete beginner? I think so. I mean, Khan Academy, it goes up to calculus now. So it should do limits.
Nice.
All right, let's try to do it using logarithms maybe, though. Here, let's do this. Okay, so let's say the limit as n approaches infinity of 1 plus 1 over n to the n is equal to some value. Let's just call this value a. Okay. Whenever I see exponents, a nice thing to do with those is called logarithms. So I'm gonna take the log, or let's do the ln of both sides. Okay. Doing so is gonna pull this. Well, let's pull the ln inside the limit, right? That's gonna pull this down. Because the ln of a to the x is the same thing as x ln of a. Is your mic working, River? Because I can't hear you if you're talking, but it's okay. So then, this is the limit as n approaches infinity of n 1 plus... If you're going to use natural log, don't you already know about E? I know, technically. He says, come on, dog. I think the Discord side just isn't working. Oh. I need an extra ln in there. Sorry, yeah, ln. Sorry, extra l. ln of n. ln of n. ln. Or no, it's, sorry, n ln of this, so, right? Thank you. Yeah. Cool. Oh, wow. Thank you, KCO, for the donation, dude. Thanks, bro. KCO.
Queso Prime 9 just donated $1
Thank
to
you, Queso.
Actual Education.
Wait, why is this not working? One second. Let me reload this. I don't know why this isn't working. Give me a second. Alright. Internet's doing a lot of weird things today. Okay. So... I don't like n going to infinity here. So let's maybe... Because I think I want to kind of do like L'Hopital's rule here, right? Can I do L'Hopital's rule? Is that the way to maybe do this? Good. Yeah. Put 1 over n on the bottom. Yeah, exactly. Yeah. So instead of saying n times this, I'm going to say this divided by 1 over n. Okay. Now we have a 0 over 0 case, right? Because as n approaches infinity, this will go to 0, this will go to 0. ln of 1 is also 0. And 0 over 0 is indeterminate, right? So this right now gets me 0 over 0, which is a great example to do L'Hopital's rule. So let's take the derivative of the top. So derivative of the top is going to be... So the derivative of ln is just 1 over 1 plus 1 over n times the derivative of 1 over n. So what? So times negative 1 over n squared, right? I differentiated that, right? I did that correctly, I'm pretty sure, yeah? And then the derivative of 1 over n is now negative 1 over n squared. Oh, very cool. Not negative 1 over n to the n. Aha. Can't you split the ln? How are you going to split the ln here? Oh, I see. Oh, I see. You were going to do this n over n, n plus 1 over n. That works too. Yeah. So then here, you go ln... Sorry, limit as n approaches infinity. So now these things cancel by algebra. And I'm just left with 1 over 1 plus 1 over infinity is equal to the ln of a. And then 1 over infinity is 0. So 1 equals ln of a. So then a is equal to e to the 1, which is equal to e. Wow. Jeff says that doesn't really help because you're assuming what you're trying to prove. Am I assuming? Why am I assuming anything? ln is defined as ln of... You could also do log of n is equal to 1. Yeah. The other way she was talking... So Becky was talking about this. We could have also written this as ln of n over n plus 1 over n over 1 over n, which would have been the same thing as ln of n plus 1 over n over 1 over n. But wait, how does that help me? Because what? This becomes then ln of n plus 1 minus ln of n all over 1 over n. Wow, thanks for the donation, Haji. Look at that. We're getting donations like crazy today. We're gonna eat good tonight. Thanks, guys. Let f of x equal the limit as n approaches it. To prove that f of x equals Mavort, cool, is e to the x. Show that f prime of x equals f of x and f of 0 is equal to 1. Yeah. It's more of a proof that it approaches e. Yeah. Yeah, no. Yeah, okay. I don't think we're proving that this is equal to e. I think we're just proving that this limit approaches e. E is technically defined as... I want to say it's a series... Is there a series definition of e, which is kind of the same as a limit? Or maybe this is the definition of it. It seems to be... Dude, where is Zach? I want to shout out Zach. I need Zach to... Zach needs to come defend his namesake. Shout out to Zach. You have the infinite sum for pi? I've seen that one before too. Yeah. But this is the other one, right? I've seen this before. I've seen this definition. The sum of as n equals 0 to infinity of 1 over n factorial. But also the Taylor expansion. Nice. Okay, cool. All right. I think this is a good question, River. I appreciate it. Thanks, dude.
Well done.
X to the n over n factorial. That's a Taylor expansion. Yeah. Okay, cool. All right, let's see. River's question done. So we got a complex question from Becky coming up next. And then Lane Pigeon. What's up, Lane Pigeon? Let me pull it in. Ooh, I like Lane Pigeons, by the way. We will do this later. Lane, if you hang around. I think this is fun. Yes, I'm like, this has to do with, torque and center of gravity and like whether things are stable or not. Yeah, let me do this question real quick, Lane. Hopefully it'll take like 10-15 minutes and then I can go and help yours out. Is that cool? Just because, let's see. Or I might do like one part of these questions. Do you do thermo and fluids? Yes. As long as it's not like super engineering thermo. You know, when you start doing like steam and turbines and shit, that stuff, I don't know, it's like, it's a little too technical. I mean, I can do like, you know, PV NRT and, you know, what's a Carnot cycle and stuff, but. Okay, and then let me get the original thing for the complex question. It was this. Yeah, engineering stuff. I can try, but I'll just warn you that a lot of that tends to be really just jargony. Which means that it's just like individual there's a lot of like acronyms and like very specific things that aren't generic. Oh, River says, can you explain L'Hopital's rule? I can. Let me help out a couple other students, and I will totally go through L'Hopital's rule. L'Hopital's rule is really cool. It basically says that if something's indeterminate, then the limit of that is the same as what the limit of the derivative is, and then you just like keep taking derivatives until you get to something that's determinate. Okay. We did all this. Z1 and Z2 are complex root of the given equation. Yeah, it sucks, honestly. Yeah, all the engine, I don't know, it's just a lot of it is kind of memorization because there's like heat of steam. It's like heat of fusion of steam of turbine of this coefficient. I'm just like, stop. Z1 and Z2 are complex roots of the given equation such that the argument of Z1 is less than the argument of Z2. Let A be a geometric sequence with the common ratio this. Okay, and the first term. Do I still need this though, Becky? Yeah, exactly. Yeah, saturated. Yeah, exactly. Then there's super saturated, right? Do I need this as part of the next part of the question? I'm just curious. Becky says yes. Okay, well, let's go find it. We did do this. Yeah, we did all this. This was kind of a clusterfuck. But we did find all the roots. Alright, we're using the roots. Okay, so that was 6m and plus or minus 2 square root of 3i. Right? Okay, so 6m plus or minus 2 square root of 3i. These were like our z's. Okay. Argument of z1. What does this mean? Does this mean like the real component of z1? Is that what arg z1 means? Oh, it's the angle in polar form. Oh, okay. Well, one of my... Well, okay. So then... Okay, so... Could I say that arg 6m is less than the arg of plus or minus 2 square root of 3i m? You want to try and do the loon of Hippocrates? Maybe in a bit. Be nice to me. M is a positive integer. Yes, agree. M is a real positive integer, yeah? We do agree with that. Yeah. Yeah, arginate M is 0. Cool. I agree with that. And the other ones, right, were located, I think, up here and here. These different colors. Right? It was like this, right? Because that's what the... Wait, was there a real component to it? Because it proves that M is real. Sorry, let me go back. Tags out. No, Jeff, you have to stay. Okay. Yeah, it is given that M is real. Okay, great. Okay. All right. Let's try and do this. Okay. Let A be the geometric sequence with the common ratio this, and the first term Z0, Z1, Z2. Okay, what is Z, though? Z is this? Denote S and S sub n as the sum of the first n elements that would occupy the oppositions of the sequence A, where n is a natural even number. Prove that Sn represents a real number. What's up, single whole life? Okay. So what? I mean, I'm just gonna try to like speak from what I know. So I know Z is a variable, right? Yeah, Z1 and Z2 are the roots. Roots of Z. I know when I have a geometric sequence, right? Geometric sequence is always like some A1 R to the n minus 1, right? And then this is n equals 0. Sorry, n equals 1 to like infinity. Yeah. So A1 we said was equal to Z0, Z1, Z2. And if R is the common ratio. Why this problem again, dude? It's torture. Yeah, I will stick with this for like maybe 5 minutes, and then I might go just help other students that need more help. But Becky, I'll come back to this, like, if there's something wrong with it. I appreciate the torture. It's fun to like learn new things. Okay, but anyways, I think this is Z squared over the square root of 6 plus the square root of 6i. Supposed to be a Z2 on top. Is it a Z2 squared? Jeff has to... Okay, so it's just Z2. Okay, cool. Let's fix that. Cool. So Z2 was the higher one, right? So that's going to be the minus square root of 2 minus 2 square root of 3i. Do we agree with that? ChatGPT. No, it's okay. You're trying. Sorry. No. This was the third root, right? So this is the one that had the higher argument, I think, no? I feel like it did. Because we did e to the 0, e to the 2 pi over 3, e to the 4 pi over 3. So this is just Z2. And then we have square root of 6 plus the square root of 6i. I think it has to be less than 360, right? Okay. I know this is real, right? Because Z0 is real. Z1 and Z2 are complex. Two complex numbers that don't have real parts just becomes like another real number. So I know this is real. The question is this real, right? Because then it's this. Oh, wait. But yeah, then it's another real number. And then this is to the first power, right? Plus this to the second power. Yeah. And so forth. And you want me to know that the sum of the first n elements that occupy the odd positions of the sequence A. Okay, so like this position. Is this considered an odd position? I always forget if the index is 0 or 1. But no, S1 should be the sum of the first term. And this is the first term. It's not the 0th term, right? Even though it's the 0th root. Okay. So we just have to show that... Okay, let me just see what this is. So Z2, I think, was... This problem is sadistic. Becky likes to hurt us. It's okay. She likes the pain. Okay, here we go. Square root of 6 plus square root of 6i. I already know this is real, so let's just fucking prove that this becomes something nice. And I think it does. I'm gonna multiply the top and bottom by the same complex conjugate. I believe it is fem. I believe it is. Oh, but it wasn't here. Okay, Becky, I think there are a lot of problems with the LaTeX on this. Here, let me go through one sec. Double check that LaTeX for me, and let me help out Lane Pigeon real quick, just because she has like a physics question. And then double check that LaTeX for me. All right, Lane, what's up? Okay, here we go. Okay, part of riding a bicycle involves learning at the correct angle while making a turn as seen below. To be stable, the force exerted by the ground must be on a line going through the center of gravity. The force on the bicycle wheel can be resolved as two perpendicular components. Sure. Parallel to the road, which must provide centripetal, and the vertical, which must provide the weight. Show that theta is defined below is related to the speed and the radius of the curvature in the same way as for an ideal banked roadway. Very cool. Okay. Yeah, so when they're talking about the ideal the banked roadway, that's this question. This is a case actually where you don't rotate the coordinate frame. So if you have this, for instance, and it's going around in a circle this way, you end up actually not rotating the whole inclined plane to like make it like this. You don't do this. The reason being is because as this thing moves in a circle like this, right? There will be centripetal acceleration, and that's to the right. And so then we have to figure out this, right? This is like force gravity. This is going to be force normal. So what you end up doing is you break up the normal force now into X and Y components in this frame. And then I believe you also have sometimes like friction. So friction can either like keep it up, or friction can like prevent it from like sliding off. It's going too fast. Yeah. So this is the way to do this one. But let's see for yours. So, yeah, that's a very important one to do. Okay. Right, fnx and fny. Exactly correct, Z. Yeah, you have to break up fn into x and y components. Usually you break up fg, right, into x and y components. But in this case, you break up fn because your acceleration is pointing in the x direction in the regular frame. Okay, cool. Okay. Free body. They already gave you the free body diagram. That's kind of nice. F is the sum of Fn and Fc. Wait, why are they calling it Fc? Wait, is it the force of friction? Are they calling centripetal force? I don't like calling it. It's not an actual force. Oh, man. Yeah. Oh, Fc I think is friction. Yeah. Okay. I don't like the way they draw this. This is bad. Okay. It is a lot of material. Yeah, no, I agree. But wait, here's the interesting thing. I see, because the force comes through the wheel all the way through. No, that's cool, that's cool. No, Becky, we'll go back to it when I have time. You got it. It's from the textbook. This textbook sucks. This textbook is a piece of shit.
What the fuck is this piece of shit?
Okay. Alright. If we were to consider, sure, just the center of gravity of the person, they do have weight pulling them down. Okay, so let's do that. So you have mg pulling them down. And then you have, sure, the normal force from the road, which is going to have a couple components, right? So you're going to have the frictional force here, which is, we're going to say like Fnx. And then you also have kind of more of the up-down normal force, which we're going to call Fny. Now, because the bike is not moving up or down, right? That means that the sum of the forces in the y direction, which is Fny minus mg, this must be equal to 0. Okay? And let's get some angles here, right? So, if they're calling this angle theta, okay, what I usually like to do is just kind of extend this arrow up. So we can kind of like see what's going on. And what I do is I kind of like make like two transversals, right? See how this is a transversal? So that tells me that this angle theta is also equal to this angle here. Do you guys remember this from like pre-calc? Like if you have two parallel lines and you have a line going in between, that's called a transversal, that the corresponding angles are the same. Okay. So that actually tells me that this theta here is really this. This is theta. So yeah, that's going to switch up the sines and cosine stuff. Yeah, so let's make sure that makes sense. The other way to do it is to then also realize, right, that this right here is like 90 minus theta. Because this is also 90. So, yeah, let me do the 90 minus theta. How do you know if it's sine or cosine? We're going to explain that real quick here. Okay, so this angle right here is going to be 90 minus theta. Which, if this is 90 minus theta and this is 90 degrees, that means this is also just theta. That's another way to prove it. So, some of the forces in the y direction has to be 0. Then the sum of the forces in the x direction, which is only Fnx, has to equal to the mass times acceleration in the x direction. If something is moving around in a circle, okay, if it's moving around with like some velocity v, right, which we can kind of see if we were to look at it vertically, so this is kind of like the perspective shift. So from the top, when something moves around in a circle, it has centripetal acceleration inwards. But then let's like kind of like look in from the side. That centripetal acceleration still points inwards, and in this case is pointing to the right. Okay? And so your acceleration in the x direction, which is this axis, has to now be AC. And so you're going to get that Fnx is equal to m, and then this is v squared over r. So centripetal acceleration is v squared over r. I don't really like using centripetal forces. Just think about what the acceleration needs to be. And then centripetal force kind of refers to like what force is responsible for providing that acceleration. And in this case, it's the friction between the road, because the friction between the road and the tire is what pushes the tire in instead of letting this guy just like slip out. So yeah, I guess technically the friction is a centripetal force. I don't really like that term. Okay, so mv squared of r. What are we solving for? Oh, they just want theta. Okay, fine. Okay, so Fnx. All right. So looking at our triangle here, right? This is always the hypotenuse because it's the diagonal side. It's the longest side. So this is Fn here, right? Fnx is then opposite of theta, okay? So what I can write out is that Fnx is going to be equal to Fn sine theta. If you want to know where that comes from, let's remember that the sine of an angle is equal to the opposite over the hypotenuse. Looking at this angle, theta, the opposite side is Fnx. The hypotenuse is Fn. Oh, cool. Well, the algorithm knows what you're doing, dude, bro. It's like, here you go. And so now if you solve for Fnx, all you do is you just move this over to the right, and you get Fn sine theta is equal to Fnx. So this one's sine theta. It's a weird case. Usually sine is the y direction, but it has to do with the angle they gave us. They gave us this angle. They did not give us this angle. So you have to be careful doing geometry to figure out when you're breaking your components, like what angle corresponds to like what part of the triangle. But the nice thing is that if you ever know that one of them is sine theta, the other one is always cosine theta, because they're orthogonal to each other. Sine and cosine are orthogonal, which means they're 90 to each other, whatever. Okay, so now we can start plugging some stuff in. So Fnx is now Fn sine theta is equal to mv squared over r. And then from this one, we can sub in for Fny, and we'll say that like Fn cosine theta is equal to mg. Okay? So now I have two statements here, right? This came from our x direction, this came from our y direction. I'm going to do this really cool thing. It's a nice trick in math. So this is like equation 1. And this is equation 2. I'm just going to do equation 1 divided by equation 2. And watch what you get, right? So if I just divide equation 1 by equation 2, I divide this whole thing by this. So now the FNs cancel. Right, cancel. Cancel. This becomes sine theta over cosine theta is equal to mv squared over r divided by mg, but dividing is flip then multiply, so that's times 1 over mg. The m's cancel, and you end up getting v squared over gr. And then sine of theta over cosine theta is the tangent of theta. So then now if you want to solve for theta, you got to take the arctangent on both sides. That goes away. And you're left with theta is equal to the arctangent of v squared over rg. Yeah. Which is what they wanted, yeah. See, right? That's what they wanted. Does that make sense, Lane? How we did that? Yeah, nice. I'm glad. Glad it made sense. And then they say calculate the theta for 12 meter per second v with a radius of 30. Yeah, thanks for breaking it down. You're totally cool. Yeah. And then just, yeah, plug values in to get theta for the last one. If you wanted it, it was tangent -1 of... Sorry, what was it? It was 12 and 30. So that's 12 squared over 9.8 times 30. When you do this, you want to be careful that you're in degree mode for your calculator. So go to mode. Oh, we're in degree mode. That's great. Okay, cool. So I'm gonna do arc tangent of 12 squared, which is 144, over 9.8 times 30. And that's gonna get us 26.1 degrees. Cool. So that equals 26.1 degrees, and you're done. Don't use radians. Yeah. I mean, do use radians if you're dealing with like angular velocity, like that's radians per second. You don't want to say like degrees per second. River says, I feel like my question's more like just asking to share things I find fun and understand them more. Yeah, that's cool. I appreciate those kinds of questions. I really do. I say learning happens at all levels. So some students need to just know how to get the right answer, and it's more procedural, and I think that's totally valid because they want to make sure that they know they can do it. If I have a student who doesn't really understand, for instance, how to do their limits homework, and they can't get the right answer, I don't want to jump right into explaining epsilon delta or explaining like the theory behind it, because that'll just confuse them more. That'll just scare them. Like, if students can't understand procedurally how to like mechanically get the question right by doing like do this, then do this, then do this, it's already lost. Any type of like theoretical thing, in my experience, in my 20 years of tutoring kids, if I have a kid that doesn't understand how to just get the right answer, but I try to show them theoretically, they're going to tune out. They don't fucking care. Because they're like, I can't do this. They throw their hands up, they're like, I can't do math. So I think it's important to at least first show students that they can do math. They're not dumb. They're not bad at math. They just, they don't, figure out why procedurally they can't do things. And then once that self-confidence has been built, you can move on into, okay, well, let's see why this works. And like, let's get an appreciation for it. So yeah, River, your questions tend to be more at the end of like why they work, which is also very important and very, valid to like go over. But for some students who, again, just, and this is why when, I'll just give you like a little breakdown into like what my teaching strategy is. When you first asked this question, for instance, right, you said, hey, evaluate this. Like, I know the answer is E, right? But to most students, this looks like gibberish just right off the bat. They're like, what the fuck is this? I don't know what's going on. So I was like, okay, wait a minute. This is something familiar that you've probably seen in your class, which is manually, mechanically, procedurally calculating compound interest. And so once you show them this, they're like, oh yeah, I've seen that before. I understand that. Like, that's not Chinese. Like, I know what this means. So you go through this and you show them, oh, here's like some real world stuff. It connects. They don't think it's boring math nerd shit. And then you say, okay, but would you like to know how this formula you memorize turns into this formula you memorize? And it's like, okay, let's look under the hood. And then students are interested to look under the hood because they at least know how to drive the car. If you don't know how to drive a car, you don't give a fuck what's under the hood of the car. But that's my mentality on teaching. End rant. Okay. Good question, Lainey. Appreciate it. Let's see. Lainey was question number 2, so let's clear number 2. Becky, I have yours. We'll still do it if I have time. Let me see. I have Lucas proof problem. Your name is the same as Lucas? Okay, great. Hello, my name is Lucas. Okay, is this your question, Lucas? Yeah, let's look at the this is the queue so far. So we got Lucas, Ryan, Haji, River again, Jay, and then Becky, the final try of the complex. You know, I should also put like a timer. I should let people know when I have to end streaming, so that I don't want you to hang around if I'm like not going to get to you. I do have to go in 30 minutes. Yeah, just heads up. I have to go in 30 minutes. Let me set a timer. One sec. Okay.
It's for 34 minutes and 6 seconds.
Cool. We got 34 minutes. We have a timer for 34 minutes. We got to get all these done. All right, let's try and do it. Yeah, you didn't screw up the commands. Yeah, you're good. All right, let x of n be a sequence of numbers such that this, and let y of n be a sequence of numbers such that this. Prove that the limit as n approaches infinity of y of n is equal to L. Is this just the squeeze theorem? So, if x of n minus y sub n is always less than this, then that means it's always less than this, but it's always greater than this, right? Oh, I'm sorry if they brushed you off. Yeah, that's unfortunate. Yeah, wait, how does this work, sorry? Yeah, you're very welcome, Lainey. I'm glad it made sense to you. You need a minus there. Yeah, sorry, this is what I meant to say. My bad. Okay, cool, right? It's okay, Becky. I appreciate you trying. Okay, so, yeah, this is absolute value, right? Absolute value of x is less than 3. It's the same thing as, like, absolute value of x is... Sorry, it's the same thing as saying x is less than or equal to 3, or x is less than or equal to negative 3, which you can then rewrite as an inequality that looks like this. Wait. Yeah, right? That's how we write that? Did I fuck that up? I think I fucked that up. No, wait. X is greater than or equal to negative 3. Yeah, uh-oh. We done fucked up.
You done messed up,
Alright, no. Roll it back.
Get in the hospital
Damn it.
And I just said,
We did bad math. This means that the difference between these two things is less than 1 over n. How do I write that as an inequality? Okay, are we doing... Is this epsilon delta is what it is? Cognition levels approach 0. Yeah, as it approaches. Yeah, seriously. Okay, one sec. let me reset the board. I need my brain to like reset. Ugh, okay. I feel like I want to use the squeeze theorem. No? Can I not use the squeeze theorem? You can use the squeeze theorem. I really want to. Right? Okay. Wait. Yeah, so this is okay, right? Yeah. Absolute value, so what? X over n minus y over n is less than or equal to 1 over n. Less than or equal to negative 1 over n. Yeah, cool. And then I want to prove... I feel like you can prove that, right? Yeah, 1 over infinity is 0. Yes. Yeah, so what? Let's just minus x to the n on both sides, right? Or minus x to the n everywhere, right? So we're going to do minus x to the n. Also, wait a minute. I'm going to rewrite this just to make my life a little bit easier. So absolute value of x minus y is the same thing as the absolute value of y minus x. Do we agree with this? So I'm going to write this as yn is less than xn. Sure. Yeah, you can do the epsilon. Yeah, that's called n epsilon, I think it's what it's called. Like it's similar to epsilon delta. I hate epsilon delta. Who likes epsilon delta? People they wake up on the wrong side of the bed in the morning, dude. Okay. So if you add x to the n on both sides, yeah, it's capital N. Okay. So x sub n minus 1 over n is less than or equal to y to the n, which is less than or equal to 1 over n 1 over n plus, or sorry, x over n plus 1 over n. I love Greek food. Okay. And then what we do is we take the limit as n approaches infinity, right? So this is, we know the limit as n approaches infinity of x sub n is just equal to L, right? This is equal to 0. And then this is limit as n approaches infinity of y sub n less than or equal to, this is again just L, and then this is just 0. So I think by the squeeze theorem, right? Limit as n approaches infinity of y sub n has to be equal to L. A says no. Am I not allowed to do that? I feel like the squeeze theorem's cool. We're chill, right? Clean. I feel like that's clean. Yeah. Nice. Okay, cool. I think it's good. Yeah, you are right. Okay, let me throw this into ChatGPT and just see what it says. Okay, it says it's a epsilon big N argument. Dude, this all looks like Chinese to me, man, dude. What? For any epsilon greater than 0, pick n1 such that n is greater than or equal to n1. We have x sub n minus L is less than epsilon over 2 since x sub n goes to L. Sure. Why does it have to be epsilon over 2? Could it be epsilon over 3? Oh, it says... Wait, where is it? Equivalently, just use the one-line squeeze theorem. Note that both go to 0.
My man.
Yeah, just use the squeeze theorem. Work smarter, not harder. Squeeze theorem's dope. I love the squeeze theorem. Squeeze. All right. Cool. I hope that helped, Lucas. Yeah, use the squeeze theorem. Unless your teacher's like one of those annoying teachers that says, oh, if you don't do it my way, it's wrong. No. That's terrible. I hate when teachers do that. Okay. Wow, so many fun questions. Lucas is done. Ryan, you're next. I'm gonna try. This looks like it might be painful, Ryan. And then Haji, you're up. Yeah. We got Ryan, then Haji. Yep. What's limit of x, sine of x minus x, x cubed, and y? I don't know. Sine of x over x is equal to, I believe, 1 as x approaches 0, no? That's a squeeze theorem as well. That's like the best squeeze theorem, right? You know that sine of x goes between like -1 and 1. And then all you literally do is just like put divide by x, divide by x, divide by x. This goes to 0. This goes to 0. So like limit as x approaches 0 of sine of x over x is equal to 0. Or sorry, as x goes to infinity. is equal to 0. Sorry, not as x equals to 0. There's a different one for as it goes to 0. This is not true? Yeah. Yeah. I do believe it is, thank you. No, you're right. I think the limit as x approaches 0 of sine of x over x, I think this is equal to 1. And this is a L'Hopital's rules question, right? Because originally, sine of 0 is 0. You get 0 over 0. Take the derivative of the top and the bottom. Right? So you get cosine x over 1. And then now when you plug in 1, yeah, now you just get 1. It's a famous limit. Yeah, it's a pretty cool limit. Yeah. That one is... Yeah. Nice. Okay. All right, let's spend maybe like 5-10 minutes on this. If I can't figure this out, Haji, I'll hit you up next. An infinite set of... Do some partial fractions. Submit a screenshot, dog. I'll do it. I'll do it, Tony. An infinite set of geometric series where the input integer for the next series is the lowest integer missing from the set, which will always be the next odd integer, which will... Okay, wait, what the fuck? All right, excuse me, what? Okay. How does this work? Well, holy algorithm, what the hell is this? Right. It contains all odd integers per given. Is this a comp sci? Maybe it is. Because any even is twice odd. Oh, any even is twice an odd number. Wait, what? How is 4 twice an odd number? Let's ignore that. Yeah, wait, what? Any even is twice an odd? No, twice an odd is always an even. But every even is not twice an odd. Oh, Ryan says it is comp sci. Okay, cool. It's an infinite series, an infinite set of geometric series with a ratio of 2. Okay, how am I supposed to solve this? Do you want me to like code something? Or is it just how can we prove it? Is it pseudocode? I see. Where the input integer for the next series is the lowest integer missing from the set, which will always be the next odd integer. Oh, because, yeah, okay, I think I see. I think what you're saying. Because a geometric series, and this is a ratio 2. Cool. Sure. How can we prove that this set contains all positive integers? Femvox says, for any even number, you just factor out the highest power of 2, and then whatever remains is the row that the integer shows up in. So, can we do like an example here? Mm-hmm. Okay. For the nth term, you can take out 2 to the n minus 1. Lucas says, I sent a question. If you could please review. It's very light for the less advanced viewers. Helpful for me. Yes. We're saying the same thing. Yes. The first series have all the evens, and all the first terms in all series, they're all evens. Ta-da. Or has all the odd? Oh, I see what you're saying. I see what you're saying. Sorry. So you're saying, for instance, yeah, this picks out all the missing odd numbers, right? Because you get 1, 3, 5, 7, all the way da 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 da. Oh, and then you're always multiplying by 2. Consider 536. Keep dividing out. Well, where was 536 here? Did we have 536 here? I'm curious how they don't repeat though. That's kind of cool. I guess because they keep playing leapfrog. Let me just kind of think how this works, right? Okay, here. Let me do Fenvox. He says 24 as example. Factor out 2 as many times as you can. Okay, so 2, 12, 2, 6, 2, 3, right? Now look at the row that starts with 3. Oh, okay. Every other number is even. Yes. So the first odd number, but how do I prove, sorry, that there are no repeats? Oh, because they're all unique. Oh, yeah. Because I won't ever get this will never be a 4, for instance. I see. So like another one would be like 5, 2, and yeah, whatever, 2 and 20. And then yeah. Something like that. I see. Oh, that's cool. And then, yeah, this would be 40. Yeah, once you divide all the evens, you get an odd. Divide all the twos, term by term, yeah. Say for each odd set, find what term it is in the series, then decide by the 2 to the n minus 1 for the term, and it will be the initial odd number. Yeah, that's cool. That makes sense. Okay, I think I understand what you guys are saying. Yeah, because you keep pulling out 2s. Yeah, it's like a factor tree. I like to, yeah, okay. I think I see it. Right. Like 56, 2, 28, 2, 14, 2, 7, and then I see, is this in the 7 tree? And it is. Oh. Very cool. Which row would 536 be in? That's a good example. Let's do it. Okay, so 536 would be 2, was that 260, 268? Yeah. Then 2, then 134, then 2, then 67. Oh, but now we're done. Nice. Oh, and then I would have to go all the way to 67. Okay, cool. All right, this is cool. Oh, you got me with 67. God damn it, dude. No. No. Not again.
You done messed up, Aaron.
God damn it. Fuck, Jeff. I wasn't expecting that. That was well played, Jeff. Well played, Jeff. Okay, cool. Good question there. Who was that? Ryan? I appreciate that. That was fun. Ryan says, my problem is fun and easy. Lucas's extremely easy question to end off the 30 minutes. Dude, this is hilarious, dude. You guys are being cute with the cute with the names. I'm gonna do Haji's next because Haji also donated to my stream, so like Haji gets a little bit of preference here. And Lucas, you're a fucking troll, dude. What? This is your question? He says this is Lucas's extremely easy question to end off the 30 minutes. I appreciate that, Lucas. I like the joke. That's funny, dude. Nice. I'll give it to you. That's really funny. All right, let's see. Sorry. I got... Extremely easy question. Prove Goldbach's weak conjecture. Square root of d over 4.9 and the square root of d over 10.8. All good. So we have... sorry, is the square root over the whole thing? Oh, I think it is anyways, right? Yeah. Okay. Yeah. Because this is 2h over g. This is a common thing in kinematics, right? And then this is the square root of d. So this is on the Earth. Yeah. So yeah, it's 2 square root over a. Yeah. Okay. Yeah. This is the main thing, right? Yeah. So yeah, x is equal to x naught plus v naught t plus 1/2 at squared. So if something has whatever, like falls at 0, has an initial height. Let's call this h. No initial velocity. And then you always consider that the acceleration is pointing down anyways. So whatever, there's a minus sign. What you'll get is that 2h over a is equal to t squared. So 2h over a square rooted is equal to t. What's up, Bobby? Bobby the goat. That's all you did. Yes. Okay. So that comes from this. All right. Here are the rules. Okay. Determine the rule for calculating the difference between the freefall times of an object falling from a certain height and that. I like this. This is cool. Nice. Okay. So from a certain height, and let's say the certain height is d, okay? So I think we kind of just did this, right? So 0 is equal to d, and then it's going to be minus 1/2 at squared. Oh, okay. So t Earth is just going to equal to... What's that? Sorry. I'm a little tired. 2d over a. Oh, we already had this, right? Oh, yeah. Okay, yeah, we did it. What's up, Joanne?
Good job.
Which Joanne is this? Is this my Chicago Joanne? The one whose family loves her very much? I have a lot of... Yeah. 4.9 what? Apples? Joanne says, ha ha ha. Yes, you are right that it should be smaller. Yeah, this 10.81 is wrong. It should be 0.181. I agree.
That's dope.
Yeah, because it's 1/6, right? Gravity on Moon is 1/6 the gravity on Earth. Okay, so yeah, it's 0.81. Okay, got you. You're good. You're good, Haji. Good. Okay, so the difference between the free fall times would be this. So it'd be the square root of 2d over oh, I see, but this is already 2 over d. Okay, so it's just square root of d over 4.9 minus the square root of d over 0.81. And then technically this one's bigger than the other one, right? So, yeah. Let's move this over. Cool. Does that make sense, Haji? Where that comes from? How can I submit a question? How? There's a website there. actualdiscord.com/submit. Yeah, submit a question. I'll do it. Determine the ratio between the free fall time in seconds. Oh, the ratio. Well, then we just divide them. Simplify, Jeff. What do you take me as, dude? Okay. So the square root of d over 0.81 divided by the square root of d 4.9. Okay. The d's just cancel. No d's. So that's just the square root of 4.9 over 8.81, which I think is 6. Correct me if I'm wrong. I think this is that gravity is 6 times whatever. That's what I remember seeing it. 4.9 divided by 0.81 is 6, but then it's the square root of that because it's times squared. Square root of 6, correct. Yeah, so 2.45. Nice. Good job. Wait, what's my thing right here? Goddess Frequency says, are you good at applied calculus? Yeah. Yeah, I'm super good at applied calculus. I can totally do applied calculus. What's the three-body problem? Yeah, the three-body problem is you can't analytically or symbolic. I think numerically you can solve it, but in terms of just variables, you can't solve for the motion of 3 objects with gravitational pulls on each other. We can do it for 2. Can't do it for 3. Not that it's really needed. Yeah, exactly. Jeff has it right. He said there's no closed form solution for it. Yeah, closed form means there's no like nice equation you can write out. We just can't write out any equation, even if it wasn't nice. You just can't fucking do it. All right, cool. So that was Haji. Let me see. I should do yours next, River, but because let me help out someone who hasn't asked a question yet, which I think I'll help out Jay real quick here. They made the Netflix show into a real thing. Wowza. That's too funny, Becky. Apparently that show is like contentious. When I was on that podcast with Tiny Toxic Tofu, she told me to suggest like some sci-fi thing that I had been watching recently, and I've been reading Dune. I'm on to God Emperor of Dune. I think it's like the second to last book of Dune. But like TV show wise, I'm like, I don't really watch that many TV shows, especially not sciencey ones. So I said, oh, I heard the three-body problem is good. And apparently the whole chat was like, oh my God.
You done messed up,
It's like, she hates that show. Or like, we all hate that show. And I was like, okay, I don't know. I haven't seen it. People keep telling me it. Okay. This is an engineering question. It's circuits, technically. Yeah, all this stuff is like so very specific, dude. The circuit stuff. Okay. These are transistors. I'm just gonna paste the answer for it because honestly, this isn't really much of a thinking thing. It's you just have to learn these definitions. So here you go. I'll throw it in chat for you. I trust it. This looks about right. So it has to do with like collector current. Beta is like a parameter that talks about I think it's like the breakdown like voltage or some shit. Yeah, and then B is the base. So you have like base current, which is IB. You have collector current, which is IC, and then you have voltages between the base and the electrode. Maybe I don't know what it is. Imposter. Yeah. It's okay. Yeah. This is double E, which when people ask me like really specific engineering questions, I'll try to solve them, but if it's just literally looking up like formulas, just look up the formula. Yeah. Oh, Reki Rek and Becky Beck. Oh, Reki Rek and Becky Beck have the similar name. That actually is kind of funny that you guys do have like similar names. Okay. It's a Spider-Man name? Is that where it comes from? That's pretty cool. All right, let's see. So that question was here. I did. Whose was that? That was J's. Let me see. I want to see something that looks like solvable that I can do really quickly. Because I have... Ooh! This looks nasty. Nasty math coming up. Oh, it's the 2 Spider-Men. Dude, I know it. No, dude, it's like the 4 Spider-Men. What are you talking about? Like, Spider-Man pointing mean? You talking about this one? Isn't it like 3 of them? Yeah. Or it's like 7 of them or something? Oh, I see. They've turned it into a meme with many of them. It's... Well, apparently it's 2. I think it is 2 originally. And I think they added a 3rd. And then they just started adding more of them. The original is just 2. But they recreated the meme, I think, actually with the actors as 3 of them. The original apparently was 2. Yeah, it's an older meme, sir, but it checks out. Okay, all right. I got 4 minutes. Make a substitution, express the integrand as a rational function, and then evaluate the integral. Oh dear. Oh dear. Oh dear. Okay. I think what I'm going to do is I'm going to say that u is equal to sine of x. And then du is equal to cosine of x. dx. Because that bitch is right there. So now integral... Anytime you see something, you see the derivative of it as well. Just use u sub. So this is negative 7 du over x squared plus x. Beautiful. Sorry, over u squared plus u. Sorry. U squared plus u. du. Partial fractions. Break this down. You can factor this. So this is... I'm going to pull the negative 7 out. So we have du, and then this is u times u plus 1, right? So then I'm going to say that's the same thing as a over u plus b over u plus 1, right? Whatever, let's... Yeah. So this is equal to this. So then u plus 1a is equal to 1. And then ub is equal to 1. So does that mean b equals 0? Wait, what? Wait, sorry. What am I doing here? Yeah, okay. So... Thank you. Yeah. Sorry, that's what I'm going to say. Okay, so... Yeah. No, I got it. You're right. I'm going too fast because I know I have to leave soon. Okay. Slow down. 1 equals a over u plus b over u plus 1. What you do is you multiply each one by the opposite denominator. So this gets multiplied by u over u. This gets multiplied by u plus 1 over u plus 1. Okay. And then what you end up getting is 1 is equal to au plus a plus bu all over u plus 1 times u, right? And then this goes over here. So, what is this? U squared plus u is equal to a plus b times u plus a, right? I think so. Okay. Yeah. So, wait, I feel like I'm missing something here, though. How do I get to the u squared, though? Oh, it clears out. Oh, my bad. Sorry. Yeah, this is u plus 1 times u. Thank you. Yeah, this goes away. Sorry. Yeah, this is just equal to 1. Good. Thank you. Okay, so a equals 1. And then you need this to be equal to 0. Oh. Stop. Okay, I gotta go really soon here. So b is equal to -1. I have to end the stream right now, Sean, unfortunately. So, yeah. 1 over u minus 1 over u plus 1. -7. Integrate. So this is -7 ln of u. So ln of sine of x. Minus 7 ln of sine of x plus 1. Cool. And that should be it. Right? I think that's it, yeah? Okay, cool. Awesome. Done. Nice. Good. Oh, plus. Sorry, yeah, there's a plus. Sorry, minus, plus. Yes. Thank you. Plus C. Don't say plus C. Okay, cool. Alright, I need to clear the stream out. Alright, thank you everyone for coming to Actual Education Office Hours today. Really appreciate all the questions. Yadavir, I do see yours right there. I unfortunately have to go. I have students who are waiting on me. Okay, cool. Thank you guys for coming around. Our next stream will be tomorrow. That's at 5 p.m. Pacific, 6 p.m. Mountain, 7 p.m. Central, 8 p.m. Eastern. If you ever want to figure out when we're streaming, just go here to actualdiscord.com/submit. We have a whole panel here. This has the calendar. You can see when our streams are. We have our very awesome friend, Zach, who's streaming tomorrow. He's going to be earlier, 1 to 4 o'clock. So, yeah, if you're looking for some earlier afternoon math, go make sure to check out Zach. His stream is on Twitch. Just click his last thing here. I'll fix it so it also has his Twitch address. All right. So now what we're going to do is we're going to go raid somebody. I always like to support another streamer on Twitch. So let's see. Who else is streaming math or science today? So we got Science, Aegis, Walking Stick, Renanda Bot, Thug Shells, Neon Guts, Astro Connect. There's actually a lot of people on today. This is cool. I like Nerduino. He's kind of a space guy. Turtle Tuesday. I don't know if I want to talk about turtles. Yeah. Okay, cool. All right. Go say hi to Nerduino. He's awesome. All right. Awesome. Okay, cool. Another W in the books. Y'all have an awesome Tuesday. We will see you tomorrow. Peace.